In this video, we will learn about irrational numbers. So first, let's review what rational numbers are. Remember that rational numbers are any numbers that can be expressed as a fraction of two integers, where a can be any integer you want, and b can be any integer except for 0. One thing that we focused on is that rational numbers can be expressed as repeating or terminating decimals. Some examples of rational numbers are -9, which can be expressed as the fraction -9/1, 3/2, which is equal to 1.5, 21/5, which is equal to 4.2, and then -1/9, which is equal to -0.1 repeated. Now let's talk about irrational numbers. An irrational number is any number that cannot be expressed as a fraction of two integers a and b. Irrational numbers do not have an ending point nor repeat. The most basic irrational number that is commonly seen is the square root of 2. Whenever you put the square root of 2 in your calculator, you get this really weird decimal that's equal to about 1.414, and then a whole bunch of numbers after that, and goes on forever. The square root of 2 cannot be expressed as a fraction of two integers because the square root of 2 is not an integer. Irrational numbers always have a square root around them. And another property of irrational numbers is that there is not a negative sign on the inside of the square root. So now let's classify some numbers as rational or irrational. Our first example is 3. Since 3 is an integer, 3 is a rational number. No questions asked. Our next example is the square root of 55. Whenever we plug in the square root of 55 into our calculator, we get approximately 7.416, and of course it goes on forever. So since the square root of 55, one has a square root around it, and whenever we try to evaluate it, we get a never-ending and never-repeating decimal. The square root of 55 is an irrational number. Our next example is the square root of 25. Whenever we plug it into our calculator, we actually get 5 as the answer, which is an integer. So the square root of 25 is actually a rational number. And the reason being is because the square root of what's called a perfect square gives us an integer value. So what happens is that whenever we multiply 5 and 5 together, we get 25. And so the way it works is perfect squares is the product of two of the same number. So 5 times 5 gives us 25. So 5 and 5 are the same number and give us 25 as our answer. So 25 is a perfect square, meaning that the square root of 25 is rational. Our fourth example is the square root of 8/2. Whenever we evaluate this in our calculator, we get approximately 1.414, and of course goes on forever. And so the numerator, which is the square root of 8, is already an irrational number, and it's divided by an integer. But since the square root of 8 is an irrational number, the square root of 8/2 is also an irrational number. Our next example is -17/6. Since both 17 and 6 are integers, and the denominator is not 0, this one is actually a rational number, as we've seen before. And whenever we evaluate it into our calculators, we get -2.83 repeated. So this decimal is a repeating decimal, which is a property of a rational number. And then our last example is negative square root of 37. Whenever we evaluate this into our calculator, we get approximately -6.083 repeated, or not repeated. It goes on forever after that. And so because 37 is inside of a square root, 37 is not a perfect square, and whenever we evaluate into our calculators, we get a never-ending and never-repeating decimal. The square root of 37 is an irrational number.